The National Electrical Code, specifically Section 250.32b4, addresses the installation requirements for grounding electrodes at detached buildings or structures supplied by a feeder or branch circuit. This section dictates how the grounding electrode conductor, which connects the grounding electrode system to the equipment grounding system within the detached building, must be installed. The primary concern addressed by this code requirement is the path the grounding electrode conductor takes from the subpanel to the ground rods. The code mandates that the grounding electrode conductor be run on the exterior of the building. This means the conductor cannot be routed inside the building, for example, by running it up an interior wall across ceiling joists, and then down an exterior wall to reach the ground rods. The rationale behind this requirement is multifaceted, centering on safety, accessibility, and the potential for induced currents and voltage drops. Firstly, exterior routing ensures that the grounding electrode conductor is readily accessible for inspection and maintenance. The electrical inspectors can easily verify the integrity and proper connection of the grounding electrode conductor and the grounding electrodes themselves without having to enter the building or navigate through potentially obstructed interior spaces. This simplifies the inspection process and makes it more efficient. Secondly, running the grounding electrode conductor inside the building can create a safety hazard. In the event of a ground fault, a significant amount of fault current can flow through the grounding electrode conductor to the grounding electrodes. If the conductor is routed inside the building, this fault current can induce voltages in nearby metallic objects such as metal pipes, conduit, or structural steel. These induced voltages can create a shock hazard for anyone who comes into contact with these objects. By running the grounding electrode conductor on the exterior of the building, the risk of induced voltages is significantly reduced. Thirdly, the length of the grounding electrode conductor can impact its effectiveness. A longer conductor has a higher impedance, which can impede the flow of fault current and reduce the effectiveness of the grounding system. Routing the grounding electrode conductor inside the building can increase its length, especially if it is routed a convoluted path. By running the conductor on the exterior of the building, the length can be minimized, which improves the performance of the grounding system. Furthermore, the exterior routing requirement helps to minimize the potential for ground loops. A ground loop occurs when there are multiple paths for ground current to flow, which can create unwanted circulating currents and voltage drops. Running the grounding electrode conductor inside the building can create a ground loop if the conductor is inadvertently grounded to other metallic objects within the building. By running the conductor on the exterior of the building, the risk of creating a ground loop is reduced. In practical terms, this means that when installing a subpanel in a detached building, the grounding electrode conductor should exit the subpanel enclosure and immediately transition to the exterior of the building. It should then be run along the exterior wall to the location of the ground rods. The conductor should be securely fastened to the building to prevent it from sagging or becoming damaged. The grounding electrode conductor must be sized in accordance with NEC Table 250.66. The size of the grounding electrode conductor is based on the size of the ungrounded conductors of the feeder or branch circuit that supplies the detached building. For example, if the ungrounded conductors are 2/0 American wire gauge copper, the grounding electrode conductor must be at least 6 American wire gauge copper. When connecting the grounding electrode conductor to the ground rods, the connection must be made with a listed connector that is suitable for direct burial. The connector should be installed in accordance with the manufacturer's instructions. The ground rods themselves must be at least 8 feet in length and must be driven into the ground so that at least 8 feet of the rod is in contact with the earth. The ground rods should be spaced at least 6 feet apart. In areas with rocky soil, it may be difficult to drive the ground rods to a depth of 8 feet. In these cases, the ground rods can be buried horizontally in a trench that is at least 30 inches deep. Alternatively, other types of grounding electrodes, such as ground plates or concrete encased electrodes, can be used. It is crucial to consult with the local electrical inspector to determine the acceptable grounding electrode options for the specific location. In addition to the grounding electrode conductor, an equipment grounding conductor must also be run from the main panel in the house to the subpanel in the detached building. This equipment grounding conductor provides a low impedance path for fault current to flow back to the main panel, which helps to trip the circuit breaker in the event of a ground fault. The equipment grounding conductor must be sized in accordance with NEC Table 250.122. The size of the equipment grounding conductor is based on the size of the overcurrent protective device that protects the feeder or branch circuit that supplies the detached building. For example, if the overcurrent protective device is a 100 amp circuit breaker, the equipment grounding conductor must be at least 8 American wire gauge copper. It is important to note that the neutral conductor and the equipment grounding conductor must be kept separate in the subpanel in the detached building. This is because the neutral conductor carries current under normal operating conditions, while the equipment grounding conductor only carries current during a ground fault. If the neutral conductor and the equipment grounding conductor are connected together, it can create a ground loop and cause unwanted circulating currents. The neutral conductor should be connected to the neutral bus in the subpanel, and the equipment grounding conductor should be connected to the grounding bus. The grounding bus should be bonded to the subpanel enclosure. The installation of grounding electrodes and grounding electrode conductors is a critical aspect of electrical safety. By following the requirements of the National Electrical Code, it is possible to ensure that the electrical system in a detached building is properly grounded and that the risk of electrical shock is minimized. Remember to always consult with a qualified electrician for any electrical work. They can ensure that the installation is performed safely and in accordance with all applicable codes and regulations. Furthermore, the NEC is a comprehensive document that is updated regularly. It is essential to stay informed about the latest revisions and interpretations of the code to ensure compliance. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations meet the minimum safety standards. It is advisable to consult with the local electrical inspector before beginning any electrical work to ensure that the installation will be approved. In summary, when dealing with a subpanel in a detached building, the grounding electrode conductor must be run on the exterior of the building per NEC section 250.32b4. This ensures accessibility for inspection, minimizes the risk of induced voltages and ground loops, and optimizes the performance of the grounding system. It is essential to adhere to all applicable codes and regulations and to consult with a qualified electrician and the local electrical inspector to ensure a safe and compliant installation. Grounding systems are critical for safety in electrical installations, and understanding the specific requirements for detached buildings is crucial for proper implementation. Proper grounding protects against electrical shock, minimizes the risk of fire, and ensures the reliable operation of electrical equipment. By following the guidelines outlined in the NEC and consulting with qualified professionals, you can ensure that your electrical system is safe and compliant. Always prioritize safety when working with electricity, and never attempt any electrical work unless you are properly trained and qualified. Electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.